Yes, the jacuzzi pump motor requires ground fault circuit interrupter, or GFCI, protection. GFCI devices are designed to prevent electrical shock by interrupting the circuit when they detect an imbalance between the current flowing in and out of the circuit. This imbalance can indicate a fault to ground, which could pose a shock hazard. It is possible that the pump motor could experience nuisance trips if it is GFCI protected. Nuisance trips occur when the GFCI device falsely detects a ground fault and interrupts the circuit unnecessarily. This can be caused by factors such as, firstly, a pump motor with high starting current. The pump motor may draw high current when starting, which can momentarily exceed the GFCI's trip threshold. Secondly, grounding issues. Poor grounding of the pump or other equipment can cause current to flow to ground, triggering the GFCI. Thirdly, electronic leakage current. Some electronic devices, such as variable speed drives, can leak small amounts of current to ground, which can be detected by the GFCI. I recommend that you firstly install a proper GFCI circuit breaker or outlet for the jacuzzi pump. Secondly, ensure that the pump is properly grounded. Thirdly, use a pump motor that is specifically designed for use with GFCI protection. These motors have reduced starting current and may be less likely to cause nuisance trips. Fourthly, if nuisance trips occur, consider using an arc fault circuit interrupter, or GFCI, instead of a GFCI. GFCIs detect and interrupt dangerous electrical arcs, but are less sensitive to ground faults. A qualified electrician should perform the installation and inspection to ensure compliance with electrical codes and safety standards. The jacuzzi pump should be supported by a dedicated support bracket or base, not by the polyvinyl chloride or PVC water pipe alone. Understanding ground fault circuit interrupters is essential. A GFCI constantly monitors the current flowing in a circuit. It looks for any difference between the outgoing and incoming current. Even a small difference, as little as 5 mA, can indicate a ground fault. When a ground fault is detected, the GFCI trips, quickly cutting off the power to prevent a potentially deadly electric shock. Now let's talk about why jacuzzi pump needs GFCI protection. Jacuzzis are inherently wet environments, increasing the risk of electrical shock. The pump motor is a critical component, and any fault could energize the water, creating a hazardous situation. GFCI protection significantly reduces this risk. But what about those nuisance trips we discussed? Several factors can cause a GFCI to trip unnecessarily. High starting current is a common culprit. Motors, especially larger ones, draw a surge of current when they start up. This surge can momentarily exceed the GFCI's trip threshold, causing it to trip. Proper grounding is also crucial. If the pump or other equipment isn't properly grounded, stray currents can flow to ground, triggering the GFCI. Electronic leakage current is another potential cause. Some electronic devices, like variable speed drives, can leak small amounts of current to ground. While this leakage is usually harmless, it can be enough to trip a sensitive GFCI. So, what can you do to prevent nuisance trips? Firstly, make sure you're using a GFCI circuit breaker or outlet specifically designed for motor applications. These GFCIs are more tolerant of high starting currents. Secondly, double-check the grounding of the pump and all related equipment. Ensure that the grounding connections are clean, tight, and properly sized. Thirdly, consider using a pump motor designed for GFCI protection. These motors are engineered to minimize leakage current and reduce starting current. If nuisance trips persist, you might consider an arc fault circuit interrupter, or GFCI, as an alternative. GFCIs are designed to detect and interrupt dangerous electrical arcs, which can cause fires. While GFCIs don't provide the same level of protection against electrical shock as GFCIs, they can be a valuable safety measure in certain situations. However, it's important to understand the differences between GFCIs and GFCIs and to choose the right protection for your specific application. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, always hire a qualified electrician. A professional electrician can ensure that your jacuzzi pump is properly installed, grounded, and protected by a GFCI or GFCI. They can also troubleshoot any existing problems and make recommendations for improving the safety of your electrical system. Finally, don't forget about the importance of proper support for your jacuzzi pump. The pump should be mounted on a dedicated support bracket or base, not just hanging from the polyvinyl chloride or PVC water pipes. The weight of the pump can put stress on the pipes, potentially causing them to crack or break. This could lead to leaks and other problems. A solid support system will ensure that your pump is stable and secure. In addition to GFCI protection, regular maintenance is also important for your jacuzzi pump. Check the pump regularly for any signs of wear or damage. Clean the pump strainer to remove any debris that could clog the pump. Lubricate the pump motor as needed. By following these simple tips, you can keep your jacuzzi pump running smoothly and safely for many years to come. Now let's delve into the technical details of GFCI operation. A GFCI works by monitoring the current balance between the hot and neutral conductors in a circuit. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current flowing back through the neutral conductor. If there is a difference of more than a few milliamps, it indicates that some current is leaking to ground. This leakage current could be flowing through a person who has come into contact with a live wire. The GFCI detects this imbalance and quickly trips, cutting off the power and preventing a potentially fatal shock. The speed at which a GFCI trips is crucial. GFCIs are designed to trip within a fraction of a second, typically around 25 milliseconds. This is fast enough to prevent serious injury or death. There are two main types of GFCIs: outlet type GFCIs and circuit breaker type GFCIs. Outlet type GFCIs are installed in place of a standard electrical outlet. They provide GFCI protection for that outlet and any outlets downstream on the same circuit. Circuit breaker type GFCIs are installed in the electrical panel. They provide GFCI protection for the entire circuit. When choosing a GFCI, it's important to select the correct type and rating for your application. GFCIs are rated in terms of the maximum current they can handle and the trip current. The trip current is the amount of leakage current that will cause the GFCI to trip. For most residential applications, a 15 amp or 20 amp GFCI with a 5 milliamp trip current is sufficient. In addition to GFCIs, there are also arc fault circuit interrupters, or SIs. SIs are designed to protect against electrical fires caused by arc faults. Arc faults occur when electricity jumps between two conductors, creating a spark. These sparks can ignite flammable materials, such as wood or paper, and cause a fire. SIs detect arc faults by monitoring the electrical waveform. When an arc fault is detected, they have SI trips, cutting off the power and preventing a fire. SIs are typically installed in bedrooms and other areas where there is a high risk of fire. While SIs are not a substitute for GFCIs, they can provide an additional layer of safety. Now let's consider the National Electrical Code, or NEC, requirements for GFCI protection. The NEC specifies where GFCI protection is required in residential and commercial buildings. In general, GFCI protection is required in wet locations such as bathrooms, kitchens, and outdoor areas. GFCI protection is also required for receptacles serving countertops in kitchens and for receptacles within 6 feet of a sink. The NEC also requires GFCI protection for equipment used outdoors, such as swimming pool pumps and hot tub pumps. The specific requirements for GFCI protection can vary depending on the application and the local electrical codes. It's always best to consult with a qualified electrician to ensure that your electrical system meets all applicable codes and standards. In addition to GFCI protection, proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing a dangerous voltage buildup. All electrical equipment should be properly grounded, including jacuzzi pumps. The grounding conductor should be sized according to the NEC and should be connected to a grounding electrode system, such as a ground rod or a metal water pipe. Proper grounding can help prevent electrical shock and minimize the risk of electrical fires. Now let's discuss about the troubleshooting nuisance trips. Nuisance trips can be frustrating, but they are often caused by simple problems that can be easily fixed. Firstly, check the wiring connections to the GFCI. Loose or corroded connections can cause intermittent problems that can trigger the GFCI. Secondly, make sure that the GFCI is properly installed and that it is not damaged. A damaged GFCI may trip unnecessarily. Thirdly, try resetting the GFCI. Sometimes a GFCI can trip due to a temporary surge or spike in the electrical system. Resetting the GFCI may restore normal operation. If the GFCI continues to trip, it may be necessary to call a qualified electrician to diagnose and repair the problem. The electrician can use specialized equipment to test the GFCI and the circuit to identify the cause of the nuisance trips. In some cases, it may be necessary to replace the GFCI or to make changes to the wiring to eliminate the problem. Remember, electrical safety is paramount. Always take precautions when working with electricity and consult with a qualified electrician if you have any concerns. This is to ensure that your electrical system is safe and reliable. Now, let's talk about the importance of regular electrical inspections. Regular electrical inspections can help identify potential problems before they become serious. An electrical inspection should be performed by a qualified electrician and should include a thorough examination of the electrical panel, wiring, outlets, and other components. The electrician can identify any code violations, safety hazards, or signs of wear or damage. They can also make recommendations for improving the safety and efficiency of your electrical system. Regular electrical inspections are especially important in older homes where the wiring may be outdated or damaged. Over time, wiring can deteriorate and become brittle, increasing the risk of electrical fires. An electrical inspection can help identify these problems and prevent a potentially catastrophic event. In addition to regular inspections, it's also important to be aware of the signs of electrical problems. These signs may include flickering lights, burning smells, or sparking outlets. If you notice any of these signs, it's important to call a qualified electrician immediately. Do not attempt to repair electrical problems yourself, as this can be dangerous. Electrical safety should always be your top priority. By following these guidelines, you can help ensure that your home or business is safe from electrical hazards. Remember, GFCI protection, proper grounding, regular inspections, and prompt repairs are all essential for electrical safety. And if you're ever in doubt, always consult with a qualified electrician.